Hello everyone, thanks for tuning in. This is something new we're trying. It's going to be a video accompanying a blog that's a deep dive on a particular topic. It's something we haven't done before. So if you like it, let us know in the comments. If you don't like it, also let us know in the comments. This will just be one take, raw, unedited, because I don't own any fancy video or audio editing equipment. And basically what we're going to do is we're going to walk through this deep dive blog that we recently published on our website, where we deep dove on basically benchmarking question answering over CSV data. And so what we're going to cover here is basically a bit of background motivation, and I'll include links to this blog and all the relevant things in the YouTube description. But what we're going to come in here is background motivation, why this is an interesting problem, why we're doing this. Then we're going to talk about how we got started. We really started from a place of where we didn't have much, and so we need to get started somewhere, and so we'll talk about how we got started and why we got started there. Then we'll talk about using LangSmith to kind of debug what's going on. The end goal of this is to produce better question answering over CSV data, and so we'll talk about some of the debugging that we did. We'll talk a bit about our evaluation setup. So we measured a few different solutions here. And then finally, we'll talk about our final solution. At this point, we put in maybe about 2 or 3 days total to this, so the final solution can almost surely be improved, and hopefully some of the ideas here spark you guys to go out and improve it, and would love to see the improved solutions. So yeah, as a basic background motivation, we've done a lot of question answering over your data in LangChain. That's been one of the core things from the beginning. For unstructured data, like text, there's a pretty standard recipe where basically you take the data, you split it into chunks, you create embeddings, you put it in a vector store, and then you do some retrieval on top of that. And that's pretty standard, and we've been doing that for a while. One of the areas where we've gotten a few comments for basically people wanting better solutions is question answering over tabular or CSV data in this case. And there's other types of tabular data. There's data in SQL tables. We're actually working on something for that as well. We'll treat those as like slightly separate, although obviously they're very related. But one of the biggest areas that we've always got asked to improve is question answering over CSV data, and so we wanted to do that. We wanted to get started doing that. There's a lot of valuable data in CSV. We wanted to try to figure out how to best do question answering over it. So that's the basic motivation for why this problem, and then why we're writing a blog post about it is that we think this is pretty representative of a lot of tasks that people will do when they're trying to improve their own LLM applications. There are a lot of challenges here. The main ones being we didn't really know how to even measure if we were improving it. And so a lot of the time that we spent doing things was on gathering a data set to evaluate and then figuring out how to evaluate. And then the other reason we think this is interesting is a lot of the insights that we gathered they're not anything super revolutionary. A lot of them come down to like good data processing and debugging that. That is one of the big issues people face when building LLM applications. So we also just wanted to shine a little bit of light on that and how we think about doing that, how we did that, what tools we used, stuff like that. Okay. So that's the basic background on why question answering over CSV data and why we even wrote a blog post about this in the first place. So as mentioned, we needed to get started somewhere. We didn't really have any data to evaluate on, and this is a problem that we think is pretty common in LLM applications. Unlike in traditional ML and data science, you don't usually start with a data set because these LLMs are fantastic zero-shot learners, so you can basically start with an idea, tell it what to do, and then you have an application, and that's really good because you can get an application super quickly, but that's not that great for evaluating it because you don't have any data. So the first thing we wanted to do was come up with some data to even use as an evaluation data set. And we kind of had two ideas. One, we could come up with a bunch of questions ourselves. We could generate some, maybe programmatically, The benefits of that were we could probably do it, we could do it relatively quickly, especially if we did it programmatically. The downsides of it were that we'd be biased in what we thought the questions people would ask of a CSV might be. And we wouldn't actually get any real data on what types of questions people would actually ask in practice. And so we went for a different solution, which is basically we wanted to gather these real questions in the wild. So we set up a super simple application. We fixed the CSV. We did a question answering over the Titanic dataset. The Titanic dataset is a fantastic starter data science dataset. It's used in lots of I think it's the getting started dataset for Kaggle competitions. And we fixed that as the dataset. We put out an application where people could ask questions of this data. And then basically in the background, we logged everything to LangSmith, our logging, debugging, testing, evaluation platform. And then we also hooked up a little button into the UI with a thumbs up, thumbs down. And then we asked people to leave feedback. And so what this looks like is something super simple like this. We use Streamlit. Streamlit's awesome. It was really easy to get started. Who was in cabin C128? We can ask a question. We can press submit. It should hopefully run in the background. We'll get back an answer, and then we can leave feedback here. And so this feedback was very valuable in coming up with our data set, because let me show you what I did. So basically, this is the project in LangSmith where everything was logged. And so you can see all these different runs that happened from the app. And the code for the app is open source, so you can easily kind of see what's going on. This is the run that we just ran, I believe. Yeah, who is in cabin C128? And then we can see that it has a feedback of 1 logged here. Filtering on this sidebar here, we can now filter data points that have good scores or bad scores, and basically narrow in on data points that have some sort of label, which we can then use to add to a data set. And so I guess there's 2 parts here. One, why would we want to use, why is this helpful when constructing a data set? This kind of gives us an idea of where the model might be messing up. So users have very nicely kind of like highlighted where responses were bad, or even more accurately, where they thought responses were bad. Sometimes the responses are okay. They weren't satisfied with the realism of what this bot was intending to answer. And so we can drill in on these data points, which we think are bad. And these are really, really valuable because they represent cases where our current solution is not performing well. And so if we want to improve it, the first step is probably improving it there. So now that we have these data points, we can click in to any one. And so we can see this, we can see the trace of what happened. And so here we have this agent. The agent didn't actually do anything. It just responded from the OpenAI model. And so we can see that we have this input, and then we can see this output. And basically it looks like here, the agent didn't actually do anything under the hood. It just kind of said some Python code that you could run on the CSV, but it didn't actually do it. And so that's why the person probably gave it this feedback of a 0. So now that we have this data point, what we can do is we can click add to data set. This then presents the inputs and outputs here. Here we probably want to change the output. I don't actually know the number of cabins that there were on the Titanic. When I was doing this for real, I had a separate screen open on the side with the CSV, and I was looking at the CSV, running some Python code to basically answer these questions for real, and then writing the answer. Let's say the answer is like 42 or something like that. I can then choose the data set that I want and click add. And I'm not going to submit this because this is probably a wrong answer. But basically, that's the workflow that we did to gather a data set of examples based on the CSV application that we had here. So thank you to everyone who tried this out and left feedback. That was very helpful. We used that to gather 50 examples. So you can see the examples here. This is open source at one of the, or we downloaded this into CSV format, and it's in one of the GitHubs. So I'm not going to go into too much detail here, but basically you can see kind of like the inputs and outputs. We gathered about 50 different examples this way. Along the way, we also got a little bit of sense of what was going on, and specifically why some of the examples were bad. And I talk about this a bunch more in the blog post, so I'm maybe going to skim over it a little bit here. But basically, there was two big areas where we found some room for improvement. And to understand those two areas, let's maybe first talk about our initial solution. We figured right off the bat that to do question answering over CSV data, there would be two different components that were needed. One would be some type of basically way of running queries against the data frame, and so let's call that basically ways of running pandas or Python code to manipulate the pandas data frame. That's needed for answering a lot of questions, like how many girls and boys survived. So you need to do some sort of filtering. How many rows are there? Things like that. At the same time, we also thought, and this turned out to be pretty true, that there's probably a need for another action or another tool that an agent could have, which is basically looking things up and doing kind of like a retrieval step. And this is really important because of the some of the data in the CSV is a bit more textual in nature, specifically the people's names. And so you can have questions that reference a person's name, and it can be a little bit tricky to find you wouldn't want to do an exact match based on that. You might not even be able to do like a stir contains on that if you're running Python code. And so it's simpler to have another tool where you can do some sort of like semantic lookup based on some sort of query. And so the initial solution that we had a retriever that basically we indexed each row as its own document, created a retriever of those documents. That was one tool. The other tool that it had was basically a way of running Python code. And we had two choices here to start. One, we could have used Quark. Quark is a library written by Eugene, who's one of the people who works at LangChain. It's basically a way of letting the language model kind of have access to specific functions that it can call. So it doesn't write it doesn't just like write Python and then execute Python. It writes a program in this kind of like pseudo language called Quark, and then kind of like executes that written code language more or less. The benefits of this are that you're not executing arbitrary Python, so it's really safe. The downsides are that you have to explicitly list out all the functions that it has access to. So to start, we gave it access to, I think, 4 or 5 different functions. There were things like calculate like the average of a column, sort a column, see the top 5 values of a column, and you could execute these things in one after another as well. So you could do things like sort this column in ascending order and then give me the top 5 columns. And so much more constrained than executing arbitrary Python code. And that was one of the things we realized was a bit of a downside. People were asking a ton of questions, and the 5 functions that we gave it weren't nearly enough to cover the wide tail of questions that people were asking. And so, that was a learning for us, putting it out into the world. Is basically there's a lot of different variants of questions that people can ask. If we did, and skipping ahead a little bit, in our final solution, we kind of gave it access to just write arbitrary Python code to manipulate the pandas data frame, so it could use all of the pandas built-ins that it knows from being trained on. Another thing we could have done is, now that we had this big bank of questions, we could have come up with more and more functions and given Quark access to those and tried to fix it that way. But we opted for the slightly easier way of just letting it kind of like write what it knows, which is pandas code. The other big issue that we discovered is a really interesting and seemingly boring, it's seemingly kind of silly bug, but I think it's pretty representative of it's pretty representative of a lot of the big issues and actual difficulties of building LLM applications. And I think I have a trace here. Yeah, okay, so you can see, so this is one of the ones that we got some bad feedback on. And it's actually the question that we had in the first place, which is who in cabin C128. And so we can now see kind of like the execution. We can see we jump in, we get back this call where we filter kind of like cabin equals this. This looks pretty reasonable, but when we look at the output of the Python REPL, we can see that it's actually cut off a little bit in the middle. And so then when we go to answer, let's zoom back out here, the name of the passenger isn't displayed because that's one of the columns that's cut out. This is pretty subtle, but what is basically going on is that Pandas has max columns to display parameter, and it actually was different on my local computer compared to the hosted Streamlit app. And for whatever reason, the environment that it was running in on Streamlit had some default that was a lot smaller than on my local computer. And so when I was testing it out on my local computer, it was working fine. But then when I pushed it to Streamlit, it was not working fine. It was pretty bad. And so this seems like kind of like a random silly bug. But as I said, I think it's pretty representative of a lot of the issues that we see people running into and spending time debugging in LLM applications, which is basically there's two big areas of time that we see people, or two big areas of work that we see people spending time on. One is on prompt engineering, and I think everyone kind of like knows what prompt engineering is and why it's important and why it takes a lot of time and is annoying, so not going to go into that here. But another area that we see a lot of people spending time on is basically data engineering and getting kind of like the data to go into the prompt in a way where the language model can make sense of it. And this can involve a few different things. This can involve kind of like setting up pipelines so the correct data. That takes a lot of time. This can also involve formatting that data in the right way. And so this is an example of where the data, when it went into the language model, was not at all formatted in a way that set the language model up for success when trying to answer. We've seen a lot of bugs and a lot of kind of like instances of this where, because you've got this sequence of calls that are sometimes deeply nested, where you've got this flow of data through various layers, by the time it actually goes in the language model, it may not look as you expect it to. And so being able to see exactly what went into the language model, as well as exactly what came out of the language model and exactly what came out of each tool, is really, really valuable for that reason. So the fix here was just simply changing kind of like the max columns to display from Pandas. For the bugs that we've seen of this nature before, all of them have their own kind of like unique solution. There's no kind of like one standard thing. Like, data preprocessing matters a lot when you're trying to give the language model something intelligible to reason over. So those are some of the insights that we gathered from doing this. And I guess now I'll talk about, and all of this is in this repo that we put up, LangChain benchmarks. We are going to add more things in here. Right now it's just question answering over CSVs. We're going to add one for SQL. That's coming soon, and we're going to do a lot more after that. And there's a bunch of different things in here. There's the Streamlit app, so the code for this Streamlit app so that you could run it if you want. There's data.csv, so we've put the 50 different examples that we gathered, the questions and answers in here. And then there's also code for evaluation. So talking a little bit about evaluation, if we look at some of the questions, we have ground truth answers, but the issue is there can be a lot of different ways of saying this that are still correct. And so the challenge is gauging whether what the language model says is actually equivalent semantically to the outputs here. And so that's what makes evaluation hard. And so in order to do that, we're going to use a language model itself. And so basically we're going to do everything through LangSmith. We're going to upload our data set there. We're going to then run test runs against a bunch of different agents or a bunch of different solutions, I should say, because some of these aren't agents. And we're going to benchmark them. These are screenshots taken from LangSmith. I'll show this in LangSmith after this. But just talking really quickly about a few of the different solutions that we benchmark. We have a pandas agent in LangChain, so we benchmark that with GPT 3.5, GPT-4. We benchmark pandas AI. This is a really cool package that's explicitly focused on question answering over pandas data frames. So we benchmarked that, and then we came up with a final solution, which is a custom agent. And so I'm going to jump into that, and then I'll jump into the evaluation results. But basically, this is the final custom agent that we came up with. First thing we did, we set the pandas display option of max rows and max columns to avoid any type of funniness in how the data is represented. This is going to be an agent, so there's a few things to think about when creating an agent. There's the prompts that you're using. There's the way that you're prompting the agent to choose a tool. And then there's the tools that you're giving it. So the first tool that we're going to give it is this retriever tool. So we're creating I guess we load the vector store here because we created it in a separate script. I think we have the script for that here as well. And so we're creating this vector store. We're loading that, and we're creating this retriever tool. And so we're giving the agent a tool that is a retriever under the hood. So it takes in a query and it returns a list of documents. And then we're just passing those documents into the context, and the agent can answer it. This here is now the prompt that we're using for the agent. And so you can see that we tell it that it's working with a pandas data frame. We then substitute in the head of the data frame. This is pretty important because we want the agent to know which columns it has available and what the shapes of those columns are and what the types are and things like that. So we give it the head of the data frame there. We enclose it in some XML tags here. This is, I've found this pretty useful for basically denoting different sections. And then we also tell it that it has access to this other tool, which, because the only column in the Titanic data set is the name, or the only textual column in the Titanic data set is the name, we're calling it explicitly that. And then we're providing like a few examples on like how it should answer specific questions. So basically telling it when it should use one tool versus the other. I had to add this in because it was getting a little bit confused about when to use the vector store tool or the retriever tool. Let's go down. We're now formatting this template. We're now creating this chat prompt template. We're creating the second tool. This is the Python REPL tool. This is pretty standard. And then we're using the OpenAI functions agent. And basically this is an agent that just uses the functions calling ability of OpenAI to decide which tool to take. And then we're initializing the agent executor. The agent executor is basically the loop that does the call agent, decide what action to take, call the tool, pass the result back into the agent, repeat until it decides it's done, or until it's reached 5 iterations, at which point it will generate a final response. We're then defining our evaluator, which is this built-in evaluator, question answering evaluator. And then we're running it on the data set. So we're giving it the name of the data set that we uploaded it to, this factory method to get the chain, the evaluation config, and then the client. This is the LangSmith client. What this creates is this creates a single test run. These are a bunch of test runs because we ran this on a few different agents. And so if we click in to a given test run, we can see each of these is a data point. They all have feedback here. We can see some summary stats at the top. This is the best agent that was ran. It got about 92% correct. We can, and actually one really important thing to note here is that the evaluator that we're using, because it's a language model, it's not perfect and it messes up. And we'll actually look at some examples where it messes up. And I think there's some discussion around whether using language models as evaluators for language models is actually okay, or whether there's errors with it, whether you should do it at all. I think My personal take is it's not perfect, but it's probably the best thing that we've got. And I've found it useful for helping to basically draw my eye to points that I should look at. So I'm not going to trust this 92% exactly. I'll probably trust the ballpark of it. And then I'm also going to know what data points to look at to see which data points failed, basically. One way to think of this is kind of like running a bunch of unit tests over all these data points and seeing which ones passed or failed. And so I can do exactly that. I can click in, again, filter on this, see which ones failed. Let's look at this one. So this is one where it asks how many people are named Charles. It uses the vector store retriever tool. Unfortunately, it's limited to only return the top 4 results. So it thinks there's only 4 people named Charles. That's good to know. Maybe we can improve that in the future. Let's look at another one. This is one where it probably, the output is correct. The reference output that we have just expresses the result in a different way, but these are basically the same, so it probably should be correct unless we really cared about the exact formatting of what we meant by a ratio. And then we can also, and then so here's another one. Please list all survivors with age greater than 50. We can see that it does a pretty good job, but it doesn't list all of them. It knows that there's 22 total, but only lists 10. And this is where kind of like having this hooked up to LangSmith so you can see the exact trace is really, really handy, because now we can see what's going on, and we can see that the Python REPL, it gets cut off in the middle. And so when it gets passed into the language model, it can see the 10, but it can't, and it knows that it looks like it knows that there's 22 total. Yeah, it knows that there's 22 total, but it doesn't know what the other ones are. And so that's why it's responding that way. One other thing that we can do with this evaluation bit is basically, for all the feedback, because the feedback itself is an LLM call, we can jump into the LLM call to debug why it's giving that piece of feedback. So here we have this QA eval chain. We've got the input of a query, an answer, and a result. We've got the output, and then we can jump in and we can see exactly what's going on inside this chain that's calling a language model to get the evaluation result. And so here we can see the prompt that we're using. We can see the instructions that are given, the format that's given, and then the output that comes out. And so it's nice to have this hooked up as well, because when evaluators are themselves LLM calls, you also kind of want to be able to inspect the evaluators and debug what's going on there. I think that's pretty much everything that we wrote about in the blog. There's a lot more details in the blog. We tried to call out some kind of like general stuff or general takeaways. Part of this is specific to the Titanic data set. That's not super interesting. Part of this is pretty general towards evaluating either CSV or tabular question answering applications or LLM applications in general. And so those are more interesting. And so we tried to call some of those out. Really, we don't think this is perfect. We think this is kind of like a step in the direction of adding more kind of like rigor and benchmarking. A pretty common use case that we heard a lot of requests for. And there's almost assuredly room for improvement. There's room for more data points. There's room for better evaluation metrics. And there's, of course, room for better solutions to this problem and doing the question answering. And so we'd love any and all contributions. Really, hopefully it's pretty easy to either contribute to this benchmarking repo or LangChain itself. And that's pretty much it. Thank you guys for listening to this. If you found this interesting, please let us know. Maybe we'll do more of them. If you didn't listen to it at all, then that's also great. Bye-bye.